Hello everyone. Today we are going to do or conduct our second class, and in this class we have to or our agenda is to solve one problem, and by that time we will understand how we have to solve the problems of Mohr cycle, and also we're gonna understand how we approach a problem when it is asked in the questions. Okay, so let's go. Moving forward, we have the question. So if I want to read the question will be: the stresses at a point of a machine component are 150 megapascal and 50 megapascal, both tensile. Okay, so both are tensile stresses. Find the intensities of normal. Okay, let me mark it out. So we have to find the normal, shear, and resultant stresses on a plane. Okay, so on a plane inclined at an angle 55 degree. Okay, so we have the theta with the axis of the major tensile stress. Okay, so the with the major tensile stress, we have to determine the uh, normal, shear, and resultant stresses. Okay, so for example, let us just draw the body. Okay, let's think that this is the body. Okay, so in this body, two stresses are applied. So one is okay, so both the stresses are tensile stress. So this is one, sorry for the bad quality of writing, 150, and this is actually 150. Okay, so another will be on this plane. Okay, so it will be 50 megapascal, this will be 50 megapascal. Okay, so we have to determine the plane, determine the these parameters on a plane inclined 55 degree with the major tangential stress. Okay, so this angle 55, and this is the plane on which we have to determine normal, shear, and resultant stresses. Okay, so let me clear this all out, and moving forward, first of all, what we have to do is to actually have a coordinate system, and remember that we have to put this coordinate system on the graph paper. So after putting it on the graph paper, what we have to do is, as we have given two tensile stresses, both the stresses are tensile, so that means that both the stresses will be positive, in the positive direction or in the positive axis. So what we have to do, we have to actually then determine this value is 50 distance from the O axis. Okay, or this is distance from the O point. Okay, okay, then this is 150. Okay, what we have 150, and now we have to determine the center point. So to determine the center point, we know that the center point will be 150 minus 50 divided by 2. Okay, so 150 minus 50 divided by 2, then we will get the distance from here to here, which is this point. And if you want to determine the distance from the O point till this, then we will actually get uh, get this point. Okay, so to solve this problem, one sec. Okay, sorry for the delay. Okay. So we have now determined the center point, so it will be 150 minus 50 divided by 2. Okay, and from the O point we can actually have the, my pencil is actually giving me a lot of pain today. Okay, so this is the O point. Okay, so to measure the distance from O point, we can add this 50 and we can get the distance from O. Okay, so moving forward, then we have to draw a circle over here. So what will be the radius of the circle? Okay, so the radius of the circle will be, okay, so the radius of the circle R will be will be this. Okay, so the radius we got, that will be the radius. Okay, so okay, now let's moving forward. Then we will draw the circle over here, and from this circle, now here comes the main part, that we have theta. We have the value of theta, which is 55 degree. But in the Mohr cycle, we will draw 110 degree. The theta will be multiplied by 2 or twice theta, that will be put it over here. So after we draw 110 degree from the center point, okay, so from the center point we have drawn the 110 degree. So this angle will always be clockwise. Okay, so from this it will always be clockwise. So we have drawn the angle from this on this plane. Okay, so this is the thing. And after that, what we have to do, after that we will draw a line which is perpendicular to the main axis. Uh, it is actually principal, and this is shear. Okay, so after drawing that, our drawing is completed. So for the normal stress will be from this point to this point, which will be OQ. Okay, and the shear, okay, so the shear stress will be this point or this. Okay, so this part will be shear stress. Okay, and for determining the maximum, okay, so if you have to determine the magnitude of the maximum shear stress, okay, so the maximum shear stress will be from on this point. Okay, this will be the maximum. If we actually see on the graph, this is the maximum point when it touches the maximum point in the shear stress, and this is the minimum in shear stress. So there is not actually minimum or maximum, it's actually positive and negative of the negative version of the shear stress. Okay, so the maximum shear stress will be this much. Okay, this portion will be maximum shear stress. Okay, and this will be the shear stress that is applicable on the 110 on the 55-degree angled plane. Okay, so it means this plane, 55-degree plane. On this plane, the shear stress will be this. Okay, and the maximum that can be applied on the major axis, that will be this one. Okay, the blue one. Okay, okay, so moving forward, we can now determine the normal stress as O to Q. This is normal stress, and we have gone the shear stress. Now we have to determine the resultant stresses. We have also determined the maximum shear stresses. Okay, so we have to determine the resultant stresses. So to determine the resultant stresses, what we have to do, we have to actually draw another line from O point to this point. Now that we have the value of OQ and the value of, let's say, this is P, so PQ, so we can actually apply Pythagoras or Pythagoras theorem to determine the this force. Okay, so resultant. Okay, so this will be the resultant shear stresses. Okay, resultant stresses. So in this way we can actually determine the values from the graph, and after plotting this case or this thing on the graph, we have, or we can actually determine these values. So these values are given for your practice, so you can actually draw this circle and draw this uh, motorcycle, and you can just check the values. Okay, and one tip for you will be that when you are actually taking the values, when we take values, we actually uh, determine, or we actually assume that one small square box equals to 2 unit, 3 unit, or 5 unit. So whatever you decide, you should consider it in both the axes. In x-axis, one small box equals to 2 unit. That means in y-axis, you will have to uh, take one box equals to 2 units. Otherwise, your calculation will vary and you will not be able to determine the uh, motorcycle in motorcycle very correctly. So you have to just keep these things in mind. So thank you everyone, and don't forget to like, share, and subscribe. Thank you.